Good morning. I have John and Scott back again. And because the numbers are going up so much on this channel, it's gone crazy the last couple of weeks. I think I will introduce them again. We'll start with Scott because he's in my upper left here. Maybe he is for you. I'm not sure because with Zoom, you never know. Anyways, Scott is a PhD expert in you don't build any robots. You just
I build them virtually.
How to use robots.
He builds fake robots.
Virtual robots. Yep.
Virtual robots. And you've been doing that for 30 years or something.
Closer to 40.
Closer to 40. We won't admit any of it.
Getting there.
All right. And then we have
fourth decade sounds better.
And then we have John Gibbs. His greatest claim to fame is that he wrote about 3 chapters in the Elon Musk mission. That is his number one citation.
That's number one on the list. Forget about the dissertation and all that other stuff. It's right there.
And if you haven't read the Elon Musk mission, then you're missing out. Anyway, John is he's also in the virtual space, mostly with AI and mostly with graphics. Would that be correct?
Yep.
And he's also the very well-known head and host of the Dr. Know-It-All Knows It All channel, where I've been watching you for at least a year.
All right, cool.
How long How long have you been doing it?
It's actually I'm working on 4 years now, and 3.5 years I've been on. I just the other day released I posted a post about it, and I had my thumbnail from my first video, and I was like, oh my, there was no gray hair at all in 2019 when I did the original video. Yeah. The pandemic and age have had an effect on the color of the hair. So.
Absolutely. All right. Well, and then I'm Randy Kirk, and if you're new to this channel, or if you haven't liked it yet, because it really helps the channel if you like it. If you haven't subscribed yet, you need to do that. You need to join John's Patreon and my Patreon. You need to follow John on Twitter and Scott and all that kind of stuff. So, but with all that said, today we are going to take a first principles approach to the entire robot issue, the entire Optimus issue. And just see what are we left with? What has to happen? What hasn't happened? What will happen based on that analysis? So here we go. The very first on my list that I sent you guys the other day is what is the real cost of the atoms to make the Optimus? For those of you who don't know that reference, Elon Musk has famously said many, many times that the first principle is to figure on a product, a physical product is what is the real cost of the atoms to make it? And that all started with the rocket when he was coming back from Russia after having his shoe spat on by the Russian a guy that would not sell him a rocket.
True story.
True story. Yeah. And on the way back on the airplane, he sat down and he sketched out an Excel spreadsheet on what it would cost to build a robot and found that it would be cheaper than buying a used ICBM from the Russians. So the real cost of the atoms, let's go. What do you guys, let's see. John, you go first.
Oh gosh, this is definitely not my expertise.
Okay, well then we'll give it to Scott.
Okay, no, but I'm just we can be rough brushstrokes at least here. That when you think about it, like the amount of metal in a cup like this, like especially if they have worked out a way to create the actuators in the robot. Now they did say the motors for the cars won't have rare earth minerals in them anymore. We don't know about the actuators for the Tesla bot, but even if they do, it's going to be a minuscule amount because they're very small, right? So, I mean, we're looking at the batteries. We kind of have a good estimate of what they're going to cost. The metals. I think you had suggested $5,000. I'm not even positive that the actual atoms will cost that much, unless they have to mine things far, far away and ship them. And there's a lot of that stuff involved as well. But the actual cost of the materials, there are, okay, we can't quite say atoms because, you can just say silicon atoms or something, but somebody's going to have to build the chips for them to put inside Optimus. So there is a fixed cost to that's beyond the atoms because they don't have the ability to manufacture their own chips. So call that $1,000 for that part. But then the rest of it, Yeah, it shouldn't cost that much. I mean, I think $5,000 might be a little bit overly whatever. It might be too much. It might be less than that in terms of just the atoms.
Okay. All right. Scott?
Yeah, I mean, if you're going to talk about the atoms, you just say, if you just melt Optimus down, how much is everything worth at that point? There's manufacturing costs and there's raw material costs. The weight of Optimus is about 125 pounds. So how much does that cost for aluminum? I mean, look it up. What's the cost for aluminum or steel?
Or plastic?
Because those are the majority of the components, and plastic is pretty cheap also. You know, the funny thing is, I think plastic actually costs more than aluminum and steel on a per pound basis, but because it's so light volumetrically, it's cheaper. Same with aluminum. Aluminum costs more per pound, but if you look at it volumetrically, it actually is cheaper. So the majority of the structure is probably aluminum. That's probably the number one material. Then I'm sure there's going to be some steel in a few places in the motors where you might need a certain amount of stiffness. These are DC motors, John, so I don't think they would be having any rare earths in it. They may not need it, unlike the AC motors that they have in there, and completely different power requirements. The only place that they're going to have maybe some rare earths might be in the batteries. We know they're 2170s. They're probably coming out of Reno or Sparks, the Giga Nevada. I think they still use. Have they been able to eliminate the cobalt and everything else from it? So it's coming from there, but it's a battery. That's it. It's just that's where the supply is. If they want to, they could probably get ones that will be a little bit different later on.
Right.
And,
by the by, just checked. The price of aluminum is $1.10 a pound right now. So we are not talking about massive amounts of money.
Yeah, I was going to say it's like a couple $100 when you melt the whole thing down. If you're going to sell now, maybe the most expensive is there's going to be probably some copper windings in the servos. But I don't think they're going to be using anything else more exotic. That's probably the most expensive material.
All right. So then if we blow that up and we say, okay, we got to add some labor, we're going to add some chips, we're going to do all that. We get back to my 5,000 number, or will it be that much? Scott, you go, because I think John already answered that.
Well, how much was the FSD board, John? Was that like supposed to be 1,000 or 2,000?
They'd estimated $2,000. So I was cutting it in half since we're only.
Yeah, you're only using half.
And
then the cameras are pretty cheap. So that might be the most expensive item right there. Second, maybe the batteries, but we're not talking about a whole lot of batteries in there either. And right now, I mean, most of that stuff, you'll be able to manufacture pretty fast. So I'd be surprised if it cost them more than $5,000 to put together. I mean, you can. I think James Dalma had made a pretty good guess. It's going to be somewhere around 10,000 or something like that. So that's probably the high water mark right there. But I just have a feeling they could bring it down under 5.
Yeah, I think the early estimates of 10,000, a lot of people were kind of guessing that. I think that had to do more with what it was as a percentage of the size of a car or something. And
but how much does a car weigh?
Right.
You know, compared to that, we're talking 100 and, you know, the weight of a passenger, and like, you know, how many passengers do you need to be equal to the weight of a car? So if you do it by that, it's, you know, 1/10, 30,000, that's 3,000 right there. You know, it's pretty cheap.
But since then, and since March 1, all the three of us in all kinds of different venues have been kicking around what is really in this thing, how many motors, you know, how many, you know, how much plastic, as you mentioned, how many cameras, the software, you know, or the chips. So, you know, I think, you know, I'm gonna stick with my 5,000 or less. I'm having a hard time getting above 5,000.
Absolutely.
Well, and I mean, without a doubt, currently, and for quite a while, the manufacturing process is going to cost far more. Now, obviously, what will happen is the manufacturing process, as they scale it, will come down, so it will approach the cost of the atoms, but it's never going to get.
But look at the complexity. There was a great video that came out this weekend on Giga Berlin. It's in German. It's about a 15-minute video, and it's a tour. And again, I'm looking at it, I'm amazed at how much automation is going on in there. And when you kind of carp, like, it took them like, 2 years or something like that, you can say, there is a lot of stuff in there. I mean, you just look at the complexity of everything. It's like hard to believe that the human mind could come up with something that complex and still assemble it that fast. I mean, first you got to build the building
Yeah.
which everyone knows that's already a bit of a project, but then they had to fill it with stuff. And look at the stuff they filled it in there. And that you had to plan that well in advance. You just didn't start rolling things in. Yeah, put it over there, put it up there. They could do that. You had to do that. That's incredible complexity to build a car. Optimus is so much easier. There's nowhere near that scale, that level of complexity that's going to be needed to bring the cost down. That's absolutely clear. And like I say, you don't need a Giga Optimus anywhere. You could be setting these things up in shopping malls and in like abandoned spaces in there. And
hey, there's one close to my house. They should go ahead and put one there.
Really, I mean, a lot of it's not going to require a whole lot of manufacturing space.
Yeah. Also one other interesting aspect about manufacturing a robot like this, cars are heavy. Like you have to have lift assist. You have to have these giant robots that move things around from place to place. Pretty much until you've got about a third of the robot put together, a person can just pick it up by themselves without any trouble at all. And even when it's all together, it's not that much. Two people could easily lift it. So.
Yeah, as we talked about in one of the other videos, you could practically send this out as a kit and put it together in your garage.
IKEA Optimus.
And if somebody besides IKEA writes the instructions, maybe I can even put it together. Yeah. Okay. Number 2, we kind of answered this already. Do we have the raw materials available to scale? Are there any raw material issues other than copper? But the amount of copper they're going to be using is almost nothing.
And copper's still only $4 a pound. So I just checked that too. This is a great website that I was on.
Yeah. My answer to that is in the AI Day 2 video, listen to the second technical presentation afterwards. It's the one by Malcolm, and it's at 3630 in there. So go to the 3630 mark. And he basically says, like, there's going to be no exotic materials because we want to scale. So we're not going to use titanium. We're not going to use carbon composite or anything like that. It should be easy to manufacture, just low cost materials because they want to get the numbers out. So that's pretty clear. So the closest they have is going to be the batteries or, maybe the FSD chip, but they're producing what? How many daily? I mean, if Berlin is putting out 5,000 a week and then Texas and all those things, like they have an ample supply of those boards. So it's not like if they're going to build 1,000 Optimi by the end of this year, that the constraint is going to be, we don't have enough FSD chips.
I was looking at 1 million for next year. Yeah. That's my real number. So
So when we get to that, again, the scale, how many batteries are in a Model Y with the 2170s? Do you know, John?
I know the 4680s. I don't know the 2170s. 4680s.
I looked it up.
120. Okay. Yeah. What is it?
It's 4,400 in a Model Y. Okay. There's 140 in an Optimus.
Right.
Do the math. Okay. So it's something like you would have to produce, I think, somewhere like 31 or 32 Optimi to be able to say, that's like one Model Y that we weren't able to produce because we use the batteries for that.
Right.
And then
and Tesla says that they are no longer battery constrained. They're no
longer battery constrained. Yeah. And they're moving away. They're going to be kind of moving away from the 2170s, they hope. They're the 4680s, so that's not going to hurt. And then even then, if you would go to that million number, I quickly did the math. I think it was like maybe that equal 31 Model Ys. 31, 32 Model Y battery supply right there. That's really going to hit the bottom line. I'll tell you, it's like, see, they're going to miss those estimates, John. Wall Street came in, they forgot about, the Optimi that are being made there. And that's why Tesla missed.
Yeah. Wait. How many did you say? How many Optimi?
He said 31. He meant 31.
31,000.
1,000.
Yeah. 31,000.
Yeah. 31,000. Okay. Yeah. 31,000. Yeah. There was a 31 in there somewhere. Okay.
Right.
So let's get that
correct. The power
so 31,000. That's still, that's nothing compared to the production that they're doing. And we know that they're not going to slow down the Model Y line because they're producing Optimi.
Right.
They're going to have more than enough batteries.
All right, here comes a big one. Here comes maybe the biggest one on the list, but can we make a basic robot that can do useful tasks? Are there any limiting factors keeping Tesla from this year making a robot that does useful tasks? Who went first? I don't know. John, go.
I'm trying to think of what they would be. It looks like they've got the brains working. It looks like they've got the vision system working. And there are always tasks that are, I mean, hell, if it's just sweeping the floor, like, you could put like those little Swiffers on its feet and just have it like shuffle around. I mean, there's got to be something useful that it can do already. I think the biggest question, I think we talked about this last time, is just a safety issue. If it is not deemed safe to be around humans, then you have to be a little bit careful about the use cases that it can be utilized in. But I mean, I think they're just, I don't know what, I'll let Scott say the other low-hanging fruit metaphor, but it seems like it's that.
I was afraid you were going to go there, John, regarding the floor. I mean, it's useful is kind of in the eye of the beholder. And it doesn't have to do everything so long as it can do something. So some people feel having an automated vacuum cleaner is good enough, it's useful, and they're willing to buy it
for a couple $100,
and
right?
put it to it, even though it can't like mop the floor or do the stairs or vacuum the drapes, it's able to do something. So we're willing to go with automation at that level. That doesn't do everything we'd like it to do, but we see that that's useful. The same thing with Optimus. We've already seen there are useful tasks we know Optimus can do, probably is already doing, and it's just going to continue to go higher and higher up the tree.
Yeah. Okay. And it seems like the useful task list is almost endless. I mean, all it has to do is pick something up and move it over here. We've seen that it can already do that. That's pretty obvious. So we've talked a lot on earlier videos. We've talked a lot about if it has balance and if the hands can be manipulated. The vision, as you said, is done. The brain is obvious. So I don't know. Maybe somebody in the comments can tell us what would be a remaining limiting factor that would keep it from doing
what we should do. And we should have done this before this meeting, which was silly. We should have just posted a poll on Twitter and said, if Optimus was available, would you buy it? And I believe that you would get a significant percentage of the respondents would say yes. Now, maybe you'd have to give it some, categories of expense and say $10,000, $50,000, whatever. But there's going to be people who would purchase it right now, even if it really didn't do much besides just look cool.
All the early adopters. I mean, there's so many early adopters.
Yeah.
All right. So another first principles approach is to take the negative. So my question number 4 is, what are the hardest issues still facing Tesla on building an Optimus? I mentioned balance and use of hands, dexterity. Are there any other major hard issues to get this thing to market? Scott.
That seemed to be it. I was trying to see if I had written down any notes on that one, and nothing jumped to my mind when I first saw that there'd be anything. It seems like they have enough dexterity going on the hands already that it's useful. The balance is all right. It can carry something. It can probably go will be going a little bit faster as time goes on. So I don't see anything that prevents them right now being able to do anything, and it's just going to get better. The only thing, and I think we will touch on that later, is it's all about the data.
Yeah,
it's always been about the data. It really has nothing to do with the hardware. It's all about the data.
Yeah. So okay. So that's a good way to put it. So the hardware and the brain seem to be adequate now, and that there's nothing really standing in the way of making a useful, saleable, ready to go product. I'm still looking at. I'm still estimating that's 6 to 9 months away, maybe even 12, but it's not 2 years away.
Okay, so if you're thinking like a saleable product, so in its current form, no, because there's going to be a lot of things they're going to have to do in order for it to be saleable outside of Tesla. Okay. So the way I look at it is, I think I've used this analogy before, is FSD works flawlessly on the test track. It's the real world that has a little bit of difficulty, and that the factory floor is the test track for Optimus. So you don't have to worry about edge cases and all these other things, and you can still make it very useful in doing a lot of things. So for the tasks that they need, they will be able to do that. And the next is going to be, the safety concerns that you might have with this, that they will be able to control them a lot easier in the environment they're in, because they're already used to having to do that anyways and comply with OSHA regulations and everything else. So I don't see any issue there. The issue is just the scaling up of the data that you want to have and getting enough of it and the repetition. And now my thought process has changed that some of that data you want to get directly in the real world in the factory. And some of it is just, this big empty room where they're going around learning to walk and pick up other objects or something like that, which is, a different kind of structured environment, but not necessarily in the factory floor.
Speaking of a good use for an abandoned shopping mall, that would be pretty. I'm thinking about what The Last of Us, when they had that abandoned shopping mall you have stairs there, you have escalators, you have all sorts of cool things that it could interact with. But I personally, just from looking at it, think that it needs to be able to walk faster to be primarily useful. But that's a pretty minimal thing. It's already close to walking fast enough.
It's a lot of it comes down to, if we go back to the Shanghai video, and you had an operator that was responsible for 2 stations. And whenever we've done simulation work for OEMs that are looking at these different human operations of what's going on, they want to look at what the utilization is on an operator. So they will provide a task and we'll go ahead and do it and say, well, based on the takt time you have here and everything else, the cycle time for that operation is well within that window, and the operator, you're only getting 30% utilization. Oh, well, okay. Find something else for them. And usually they've kind of worked it out that they will have the operator responsible for 2 or 3 stations at the same time to get it up to 85% utilization. They don't want to be above that because it's going to be, 100%, you're just not going to get that. That's unrealistic. But at the same time, they really don't want to be below 85 because then they feel they're not getting enough value from that particular operator. All right. So that's why it's designed the way it is to get the most utilization out of the operator. With Optimus, you can kind of switch that around and say, okay, if it's a little bit slow, we don't care. And, maybe it's 60, 70% utilization for that slow Optimus. And well, we can just put another one right over there.
Yeah.
Now, again, remember I talked about changing the factory floor landscape? Because they're so focused on the labor rate and getting and squeezing out the last bit of utilization from that operator, they have to make sure the operator can comfortably go from one station to the next. So you don't want to make an obstacle course in there. So that in many cases, that means where they place the dunnage, where the operator is going to grab to bring in there, is placed in such a way to make sure it doesn't get in the way for them to be able to get to the next one. Okay. So in some ways, the fact that you're making them have to do 2 operations can end up impinging on the efficiency of that particular one. And so now if you're not worried about that and say, well, they're just going to be right there and they can still get out, but they have to take a longer route around. Now I can start placing that in there. Now my corridor is a little bit different. Now my factory floor footprint changes a little bit. So it's like advantage. So you look at it from a very different point of view. You begin to realize there's all sorts of things in this factory floor landscape that are going to change when you have very different value propositions on what the cost of labor is at that particular point.
I'm going to do a video on this later this week, and I have this theory, and I think it's really well founded. When I would have any kind of new automation or big equipment brought into my factory, there was also going to be a technician that was going to show up the next day, who was going to either be part of the installation, he was going to be part of the analysis of what was going on around the factory floor. There was a guy or a gal that was going to come in and help us get the thing operational. And I think certainly the first year there is going to be an application made to Tesla. This is the use case. They won't even sell it or lease it until they know what the use case is and whether it's going to bring them valuable data. And then there will be a customer service person who will go out and go to the factory floor, help them get this robot doing exactly what they wanted to do, make sure that the safety issues are covered, all that kind of stuff. And over time, that'll become something that maybe even ChatGPT can do for them over a video. Yeah. But in the early days, I think it's going to be very much a one-on-one situation. You guys are just nodding your head.
No,
Okay.
well, no,
That's
I think, well, I mean, I was thinking a one to many in terms of bots, because maybe what they would do is a company would buy 10 of them and you'd have one person come out and work on, installing them, whatever that means. So it might not have to be one-on-one. I mean, 1-to-1 relationship between human and Optimus, but yes, it'd be small numbers of Optimi with one person coming in to do the training.
Yes. There's
So
going to be a different
really
job
cool
description.
job. There's going to be a really cool job for people to apply for. It's gonna be the guy
Oh yeah,
that's not-
yeah.
Not
It's-
quite an engineer. He's a tech kind of guy. He's social. He's fun to be around. There's going to be this. I'm going to say maybe 1,000 employees that will have that position as they roll this thing out.
Oh, and there are people that can't wait for that job. I'm seeing comments all the time from people that see the videos that they say, they can't wait. What can they do to prepare themselves for that? And the thing is, it's just, kind of working your tech skills. If you're working in a company that has robots in there already, and just show interest, because sometimes like between shifts or something like that, go up and get a little bit of interest, and who's ever running the robot will let you like take over the teach pendant, get a little bit of that pendant time, do it on weekends or something like that, set something up with your boss. So you get a little bit of exposure, and then they, might send you off to an actual official training class for it. Just show a little bit of initiative, and that will be enough. And then when the bots come out, you're going to be well positioned for it. So I'm glad to see that there's the enthusiasm. It's going to not take away your job. It's going to change it a little bit, because right now you see all those bots, all the robots that are out there. You're assuming, all those robots are just operating on their own. No. There's still someone responsible for every cell to make sure it's working, because there will be downtime in there. There's going to be consumables that have to be changed. They have to do a cycle reset. There's all these things. And so there could be 1 or 2 people responsible for one particular cell, and then, someone else who's managing the whole thing. And then someone else is on call who's able to go in and, really go in and make some changes. So no, it's not going to eliminate human labor. There's still going to be it, but it's going to be a more interesting type of human labor.
Sure. All right. So number 5, we've kind of answered. How do we get the bots to stand, walk, fall, carry various objects, have their arms in various positions in various environments with various loads? You mentioned, Scott, the other day in another video, how even when you turn on that drill motor, there's a torque issue that the arm needs to be able to respond to the torque. I think we've kind of said, hey, set up a lot of workstations, set up a lot of these bots just walking around and getting data. Anything to add to that, John?
Don't underestimate the power of virtualization as the creating the first 90% of the training. So I think, a lot of people are like, oh, you need tons of data. So I think we've mentioned this before. You would need 1 million bots out there doing all this stuff, and it's going to be impossible to gather that much. But you can get about 90%-ish of the way to where you need to be just using computers and virtual robots. And clearly they've got that already, because they've shown us that. they've shown it training. And then of course we've also got the human driver. They also showed that at AI Day 2, where they had the person demonstrating for the bot what to do using their own body. Probably with VR glasses or something like that. But anyway, so that, there's a lot of that stuff can be done in a way that you don't need the physical bots. So a few hundred or 1,000 of these things, polishing up, fine tuning the ability. Yeah, that's completely reasonable. And I think the ultimate and best argument for why they would go ahead and build that many of them this year.
Okay, Scott, anything to add?
My dad was an industrial engineer, and he gave me his perspective on Pareto's law, which, some people call it the 80-20 or the 90-10. And, his interpretation was, you can get the first 80% done with 20% effort. Right. The last 20% is where the 80% effort goes. So, John's talking about with the virtualization, it'll get you, like 90% where you want to be there. But, then it starts chasing those nines. And so that last 10% there is in some ways where almost 90% of the effort has to go in. So, but without virtualization, it would be really hard, because if that net is really blank and has no idea what to do, it won't know how to start. So when we come into this world, we have this innate capability that's just there. And then we build on top of that thing. Without that, who knows? We probably couldn't do anything. So there's got to be, some kind of configuration for the net to begin with.
Right.
And
let's not forget on that we have full self-driving as the beginning point already too. So these bots, by no means are they, even in the virtual world, by no means are they coming in with a blank net. They already have years and years of very, very hard fought training done by the Tesla FSD team.
Yes. Yeah.
All right. Well, that kind of segues into the next question then. What are the limitations on useful work? Let's assume that we are a year and a half out in my world. This is Randy's world, where we've built 1 million units in 2024. They've gotten better and better and better. They've got all this data coming in, all this visual data, all these simulations, all these engineers these technicians that have gone out in the real world and fed back all the problems they've run into, blah, blah, blah. I mean, they've really done a lot with these first 1 million units. What are going to be do you see limitations?
I think the hands are eventually going to become a limiting factor. They're probably going to have a better hand design if they want to do more dexterous type of work.
So Scott, would we just unscrew the hand and take it off and put on a different hand that would be useful for a specific task?
Possibly, but I think what ends up happening, and I don't know if we're getting this later on, obsolescence. So this bot is not meant to be around for 10 years.
Yeah,
it's a starting point. And the whole idea of the bot is not only to learn a little bit about it, but to get a return on investment on it. And as soon as you get the return on investment on your capital, at some point you can decide it's depreciated enough, I can replace it with something else. That'll be better.
So the first one of these that came out, I would buy them every year.
Right.
And then after about 3 or 4 years, I said, I can get by with a new one every 2 years.
Right.
And this year was the first year that I hit 2 years and I didn't buy a new one because it's still fine.
Still fine, yeah.
That's kind of what you're saying, Scott?
It's going to be the same thing. Now, I think the first versions, unless there was some issue with like the battery or something, they might still work, except they may not work on the phone networks anymore, because with the first ones like 2G.
Yeah.
Because now, so now like a lot of networks don't support 2G anymore, and some of them are also going away from 3G. So that's like the only reason it's obsoleted that way. And so there could be other things, but right now I don't think they're designing the hardware or anything else to necessarily survive for 10 years. They do want that data. They want to kind of find out what they can do, whether they over-engineered, where they can go down a little bit, but it'll almost be obsolete as soon as they get it ready to go out there, because I'm sure they've got like second and third ideas on how to do these things. They just have to crank them out or start working on that. So at first you won't switch it out, because when they do that, there's probably going to be all these other things they want to do along with it. And I'm also wondering how much the original data is going to work.
That's a big problem too. Yeah,
I have a feeling that remember when the hands first came out, we were debating whether there was like 3 fingers or 5 fingers, or why would they put 5 fingers on there? And some people say, well, why do you even need the pinky? No one really, they could go with 4. And there's all sorts of arguments back and forth. And I think in the end, but the finger lengths are all the same, which is kind of odd, because, your pinky is not the same length. However, every person, their hand is a little bit different. So, I mean, mine kind of looks like that. You'll see other people whose hands, have much longer here and there. And, some people, I think, I forget what it's called, where these 2 fingers are the same length, yet we can still get by with it. And the reason we're able to get by with it is topologically, we're all the same. Even though we're size different, topologically, we're the same. And my feeling is what they're trying to do with Optimus is make it as close to a human being so that it's a lot easier to train it without you having to do anything sort of special. So the mapping works right. Because once you have a completely different mapping, it doesn't work that easily. And a lot of it is going to be based on the inputs of what they are getting in the neural net. And now if you completely change your hand configuration or like some motors or something like up here, it's almost like all those outputs we were looking at are changed. We're going to have to figure out how to map it and retrain it again and again, which might be why Tesla really doesn't want to move the positions of the cameras, because it's like, yeah, it's where it is kind of good. And if we radically change it, we may have to do a lot of retraining. And now just kind of show an example is that, remember we were talking about that hand that Stanford had that did all these incredible tasks with the, the zip tie and the hoodie and everything else. But if you look at that hand, it's a weird hand that's got like 4 fingers on it that can kind of slide back and forth. So sometimes it's almost like 2 together, but it doesn't look like a human hand at all. And if you look at the operator, he's got this weird contraption that he's doing. And I'll tell you, you cannot take someone off the street and say, go in there and now try doing this, because they have to learn the coordination of that. So suddenly what they've done is they've come up with a mechanism that does not map to the human anatomy well enough that you can just say, well, I'm just like, this is how I hold a bottle like that. And the other thing is going to be, huh, what? And I've seen this with robot kinematics. We always have this issue where we have to swap one robot out for another. And so long as they're kind of kinematically similar, it works. But if you swap out an articulated arm with a Scera arm, it's just like, it's not going to do it because they're just designed completely differently. Right. So that is part of the reason they want to go in there for the training purposes. And I think as far as like how it's going to be trained, I've talked about this concept before, and that is you're going to have not a coach or a trainer. They're going to be called a sensei, which for martial arts, you kind of know from that. Basically, you've got the master who shows you what you're doing, and then the student follows along and does the same thing. So
it's bots doing wax on, wax off.
It's not, there could be some stuff with, AR goggles and VR, but it's mainly going to be, Optimus, come over here, look at this. And then you just kind of do something, and it looks at it and studies it and understands what that is. And it kind of gets the idea. Oh, that's what you want me to do. And it tries to do it. And you go, no, that's not quite right. You need to a little bit like this. And then it will say, oh, okay. And then it'll make that kind of adjustment and understand it. It's the same way like when your dad showed you how to drill a piece of wood, that's how it went.
All right. So that allowed us to answer number 7 almost there, the different ways that we will solve these issues of training included wired humans, humans with VR systems, humans just talking the robot through it, virtual reality, simulations.
But the whole thing with the wired, that's a crutch early on. Okay. That's to kind of get you going. When Optimus is out there, it's not going to be any of that stuff. Like I say, it's just going to be, this is how it's done, do it. And eventually you're just going to put a pile of stuff in front of it, and it's going to look at it and figure it out. So, I mean, the ultimate one will be, when you're one of those toys you had as a kid where you had the blocks of the different sizes, one that was like a star and a triangle, had to figure out how to put it in there. Crows evidently know how to do that. I saw like some videos of that. Like, that's amazing. Yeah. So it's got to be more or less, well, let's just put it in Optimus and look at it, and it will just sort of say, oh, look at this.
But let's not forget one major advantage. You were telling the story of like your dad or your mom or whoever showing you how to, drill a piece of wood and screw it together and do that stuff. Mm-hmm. Every single human being has had to go through that. So billions of these training sessions have happened. You only need one with Optimus. That is the cool part and the game changer. So, dad shows the one Optimus how to do this, and suddenly they all know how to do it. So that's pretty cool.
That is huge. It's huge. And okay. So let's say we go to the next stage here, which is we're actually in production. We want to be making 100,000 of these, in the first 6 months of next year. And then the second half, we'll put on a second shift and third shift or whatever. Anyway, what are the limitations on doing that? I listed 5 possibilities of tooling, manpower, brain power, space, and compute.
I'll throw in one extra one,
which
is a big one, and that's Cybertruck. And I mean that just because it's a split focus. It's like, how many engineers, time, effort can they put into this? And I think Cybertruck is going to be a huge focus next year for them to try to ramp that up to a scale of 100,000 next year or something, some major amount of Cybertrucks, and that will take a massive amount of engineering effort. It was really, really amazing, by the way, to hear Elon said that he walked the production line for the Cybertruck. Right. I was like, that is great news to hear the production line exists. Mm-hmm. That's really cool.
Yeah. All right. So I wonder if that was next to the Optimus production line.
Yeah. Let's just have a little side one over on the side where it's just
and John, I think too, though, I think the folks that they've been bringing in for Optimus is a different. It's a different person. It's a roboticist. It's somebody that came because.
Right. But I'm just talking about when we get to mass manufacturing, we just need a production line with a bunch of people working on it, right? So I'm saying eventually we're going to get to the point where it's not these engineers building these bespoke things. Yeah, that's the part at which it's going to become a conflict.
But I don't think they need to poach from what they're doing for Cybertruck or a Model Y production line. You can hire some other people to go in and put it together, because it's a completely different way of doing the manufacturing. It's radically different. Does
that mean what we should do is we should be paying very careful attention to the jobs wanted ads in the next 6 months?
Yeah. Well, you can go. Yeah, actually, you can go and you can look.
Yeah,
they're out there for if you want to see who they're hiring. And I checked that over the weekend to kind of get an idea, and so it's the impression I get is they are looking for people at least at the lab scale right now to help them with a lot of the building of these things. As far as the tooling, the only tooling I think is like, we've got to assemble some castings for probably the aluminum bits that are out there for. That's not hard to do. I mean, that's and with the 3D printing, it's even easier to do that. I don't know how much they need to 3D print or injection molding. So, that's the kind of tooling you're most talking about there. You're going to have some CNC machines. And we talked about this the other day, Randy. It's like, you can just buy them on the second or third hand market for the most part to get the kind of precision that you would need. I'm almost thinking it's like, okay, we get the part where we got to manufacture the servos and a few other things and the actual components. And then there's the assembly of the components. And you may have some tooling there, but I'm thinking most of the tooling is, hex wrenches. And the worst case, just go and buy a bunch of IKEA furniture and pull the stuff out of there if there's a supply chain problem. And you'll probably be able to assemble most of it without, just on the top of a desk, just go ahead and put it together. And then you're going to look and say, okay, what can we do to make it a little bit easier? What special little jigs or fixtures can we have that you just kind of snap it in to make sure it goes in right the first time, a lot quicker and easier. And so they'll be evolving and working on those things. And maybe when I go to put the arm together, I just have something to rest it on. But that's all really easy to put together. That's not like what they have to do with a car. So knocking out the tooling is easy. You said manpower. Plenty of people with in the trades with the expertise to be able to do
and
this.
robots.
Yeah. Oh, it doesn't have to be in robot. I mean, you can just hire a lot of people that are know how to build stuff.
No, but but the Optimus will be building the Optimus, so that.
Well, eventually when we get to that, but at first there will be no problem, and then brain power. I think it'd be space. Like I say, if they're running out of space in Giga Texas, just go to some mall that recently went bankrupt thanks to Amazon and take that place over, and which Tesla has already done, right?
Yes.
Isn't like Lathrop and a couple of others? It's like an abandoned J.C. Penney or something like that. So,
right.
Yeah. And, compute, I don't see any limitations on the compute. There's nothing to prevent you from getting to 100,000. The only thing is, are there enough use cases? Can they absorb that and everything else? But to scale up and manufacture, there really shouldn't be anything.
John, thoughts?
I agree. I mean, it's just it mostly comes down to what's Tesla's focus. How much money are they willing to throw at this problem? If they don't want to hire people and they don't want to make new lines to do this, then it's not going to happen very fast. But from all indications, it is exactly the opposite of that. And if they have to hire another 5,000 people to do this and take over an abandoned mall or just a corner of Giga Texas or whatever, then they'll do it. I think
it's all in business is always risk opportunity, right? And in this particular case, I think I don't think comment below if you don't agree, but the opportunity here is so massive,
right,
that it's hard to imagine the risk that would be too large.
Yeah, and especially for a company like Tesla, where they have a lot of cash on hand, they're not in danger of going bankrupt because they
Right.
spend an extra, $100
Billion.
million on an Optimus bot. That's not going to be a big deal. And at the same time, getting there first is a big deal because there are a lot of other companies working on this. So
Yes, there are.
so if them sitting around with their thumbs up their butts is not going to get them anywhere.
Mm-mm.
So they're
No,
highly motivated to get there first.
There's a really, really good video, and maybe we'll do this together. It's a very short video, and then an article that goes with it about a bot that's out there. Actually, the bot they're using is that dog bot, that has the
Zeus.
Spot or Zeus.
Spot.
Zeus, yeah.
yeah, so it
Wait.
has yeah.
Which one is the
And they're showing how they're training this bot already
Not Zeus.
to go and do useful tasks around the house, and training it in minutes, using just loading it up with internet content of what houses look like and what you can expect in a house and what you can expect to have to deal with. And it's actually working really well. So the ability to, get those kind of things done, these other companies are showing that it can be done. And I'm sure that the folks at Tesla are very well aware of every one of these other bots and know exactly what they're doing, so they can incorporate that into their thinking and into their approaches. Safety, limitations. So getting into actual workspace. We've talked about safety many, many times. You mentioned pinch points. You've mentioned, Scott, I know this is a specialization of yours, falling over on somebody, running it. I mean, what have you really thought it through? Are there any significant safety issues for a 120-pound, 5-foot tall bot that can't go faster than 5 miles an hour?
Well, I don't think anyone ever wants, someone that weighs 125 pounds just to land on them. So that would be the main thing, is the balance, making sure. And it may be that there'll be some sort of harnessing on it at first, just to make sure that doesn't happen. So long as it doesn't fall on top of you, if it just bumps into you, it shouldn't be a problem. But I think they need to get rid of some of the rough edges on there at first. Mm-hmm. So I would not give it the Cobot certification, just because I think there are some sharp edges in a few places in the motors. And that's why my feeling is that this is really just a pathfinder for them to understand what they have to do to train, and that they're going to be making major changes. I've already got my own ideas of what I think they could be doing, that would make it a little bit sleeker, maybe more powerful, maybe even easier to assemble, and overall safer. So a lot of it right now is because they're trying to get something that comes together and works and doesn't look at all like the initial design, which if you look at the initial design, definitely did look very friendly and unthreatening.
Right.
So that's, I think they're going to go down there at first. So, and that's why you're not going to be able to buy them right away, because they need to perfect that. And they're moving very, very fast in that area.
And that's been kind of my thought, is that a lot of these things, they might be more complex than they look, but they don't look that complex. So for instance, in training, I mean, and that's why I say I want to do a video on this later this week. If I want to train, if I have a bot that can move his arms in all these different directions and has visual capability, and I want to train him to, which everybody knows that watches these videos, I thought the coolest thing was using the drill motor. So if I want to train that bot to pick up the drill motor, put it in his hand appropriately, put on a bit if necessary, and then go over to an object and then screw it down or drill it in or tighten a lug nut or tighten some kind of nut. It seems to me that might be a couple of days of training. I mean, not weeks, not months.
Once they get it down, it should be pretty quick. Well, once they've sort of figured out how it is able to learn or understand. Yeah. So you got to get it bootstrapped up to a certain point. But once you're there, then it will probably be fairly quick for them to be able to show different tasks and the idea that it understands the concept of a task as opposed to a set of very rigid points I have to move through to go something. And they were pointing that out in the AI days, like, okay, we want to show how to pick up a box, but the box is not always going to be in front. It's going to be here. It's going to be there. So you wanted to understand the idea of, oh, a box, and I do something like this, and wherever the position is, it will then figure it out. Because I don't want to have to train it how to pick up a box from 1,000 different locations. It should just be able to figure that out on its own.
Right.
That's, that requires a lot of iterations, but eventually it'll be there. And then when you start showing it how to grab any sort of object, even if it's a different, if it already has a concept of grabbing down, the next time you show something different, it will understand how to do it. But then you might say, but this is not a bottle that you just pick like that. This is a drill, and you got to make sure your trigger finger is out like that when you do it, because we don't want to turn it on. So then it has to understand the concept that some objects actually are able to do something more than just be, a rigid body.
Yeah, John.
I'm thinking. Well, I was thinking about. I was actually thinking about these bookshelves, the IKEA bookshelves, and I was thinking that's kind of like a good test for something like Optimus, because when you think about it, even if you had it in English instead of those little silly pictures and stuff, but you have take part A, attach it to part B with a dowel, use the whatever those hex wrench things, and put it together. But when you take it out of the box, it's spread all over the floor. It's not saying go 3 steps to the right, lean down, pick up that thing that's right? So in order for Optimus to be able to put together IKEA furniture, it's going to have to understand conceptually, I need to take these 2 things together. I need to discover what those 2 things are within this realm of stuff that's laying here. I then need to figure out what the connecting elements are, put that together, and then, and then stack it up from there. That is very complicated, right? It's very different than what Scott was talking about, which is, move 30 degrees to the right, and then, 20 degrees down and 2 millimeters over. And then, stuff like that is very, very rigid and not flexible.
Yes. It's a very different idea between a task and a recipe.
Yes, exactly.
And where the recipe even gets broken down into smaller and smaller, finer elements. And again, I mean, the whole thing with IKEA furniture and directions and everything else is that whenever we get the Christmas presents as a kid, we'd open these things up and they'd always have to assemble. And my dad used to joke that the only reason for the directions is to check to make sure you put it together right. And he actually, I think that's why we became engineers, is that we would study the mechanism to figure out how to put it together.
Yeah.
And that will be the same thing with Optimus, is that it'll look at a picture on the outside and say, oh, so that's what it's supposed to look like. And then we'll look in there and then try to figure it out. Now, of course, the one thing about IKEA furniture is you think you're so clever that you know how to put it together, and you don't realize there is like a certain order of operations that might have made your life a little bit easier. And that's like where the industrial engineer comes in, because they'll see those things and go, if you kind of change the order of these steps here, things will go together a little bit better. So they will have one way to do it. And I'm sure Optimus will look at it and probably be able to come up with a better set of operations than IKEA comes up with. And then maybe they'll come back and say, okay, IKEA, here's the new set of instructions.
By the by, there's a whole task. Could you imagine just at a local strip mall or something like that, just in a store, it's like, bring in your IKEA box, the bot will put it together for $40, right? If there's a group of people who would be like, I hate putting this stuff together. Sure. Yeah, exactly.
Yeah,
right.
yeah.
So.
Now, I'm not sure. Is IKEA going to start, sponsoring these videos, Randy?
I know.
I don't know that we're saying anything really fantastic about them.
No, it hasn't. It is not like we've been throwing glory at them.
Exactly.
Yeah, it's IKEA fun.
There's no bad publicity. So.
Exactly. It doesn't matter what they say, so long as they say it. Right. It works for Tesla. Look at
That's right. That's right. Okay. So if but we go back to the Pareto principle in another way. So 20% or 80%, 20% of the work that needs to be done is going to actually accomplish 80% of the tasks that the robot can do, I think, if we use the principle. So 20% of the training should result in 80% of tasks that Optimus can do. So I look, again, I'm a very simple guy. I had a very simple factory. I look around the factory and I say the existing bot could do all these tasks right now because they're repetitious, they're boring, but they're really useful. And so but most of it comes down to being too low of a volume to go to full automation, where it's a fixed automated setup. And so you want the versatility that comes with the robot to do 1,000 a day, where an automated piece of equipment, it wouldn't be worth it till you got to 10,000 a day. So I look at all the possible use cases that could be done with minimal training before you would even get to assembling that IKEA product.
Yeah, I mean, that's not going to be the first one out of the box, that's for sure. So they will be doing something different. Yeah. And you're right about the volumes. They are extremely important when it comes to automation. And it's not because the equipment can't do it. It's because you have to program the equipment to do that. And I've seen many, many cases, and we've been brought in to many companies where they were sold some arc welding robots because, they were shown that it could do a particular work piece, and they were absolutely convinced it would do it. The problem is their batch sizes were so small, they had to keep on reprogramming the robots again and again. And you were seeing robot cells that were sitting there idle because they just couldn't program it fast enough. So you've got a day's worth of production on this thing, yet it takes you a week to program the robot. You're not going to do that. You're going to go in. And so, part of what we've been trying to do is to have like a virtual way of doing it, and these macros where they can click, 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 click. And if we cannot teach that robot to program a workpiece in the same cycle time as that workpiece, that's almost of no value in low volume. If you got something where you're putting out thousands of them, you'd be willing to spend and try, online robots, teaching a robot online, there's anywhere from a 50 to 100 times cycle time to teach time. So if it takes a part 1 hour to be welded, you're going to need 50 to 100 hours to do that. That's 1 or 2 man weeks right there to program it. So that means you need to make sure you have the scale for that. That's why all those little tasks are not being automated, is because there is absolutely no return on investment. And now worse than that, it stalls the whole process. Suddenly it's like, whoa, the bottleneck is programming the robot. So if you have a robot that's that flexible, that can go in and start figuring these things out right away, then you can start automating those little tasks that you didn't bother to do before.
So welding would be a great thing for the robot to do, because it's a safety issue as well for humans to do it. And nobody wants to do it.
It'll be interesting to see whether Optimus could do it. I think you still want the industrial robots for a lot of it, because the kind of precision and everything else that they have, that they're really set up for it. However, again, this whole Pareto thing is that I've worked on these things, and that they would like the robots to be able to do 100% of the welds, but they couldn't. You could get 85, 90%, and there were still some, because the guy had to like crawl in there and really get in there to get the access, because the robot was just too big, and go ahead and do it. So there are a lot of welds that you still have to do it. Maybe Optimus would go in and do that, but like some of the real long ones and everything else on these big work pieces that are going up and around and everything else, it probably doesn't make sense to have a human or a humanoid robot to do it. You would still try to do it with the other. The key is being able to program them quickly. And this is a question that has come up, is like, well, when they're done with Optimus and how to do that, do you think it would apply to like the KUKAs and the FANUCs that are in there, the normal industrial robots? I'm like, yes, 40 years late, 40 years too late. Exactly. So and it will be almost a lot easier that once you start to bring that in there. We get AI writing these Python scripts already. I don't think it's going to be that hard for it to figure out how to start teaching a virtual robot.
Absolutely. All right. Well, the last two we've already covered, so we're going to keep this at 10. So we looked at 10 basic principles, first principles approaches. And were there anything that we left out? Anything important? Anything critical that we didn't cover, guys?
No, I think it just comes down to Tesla's will. And I think what Scott says is very, very important. How do you absorb these robots into usefulness? So, I mean, obviously, if they would be willing to sell them, but if they're not quite cobots yet, if they're not safe enough to be used, and probably if they're going to sell them or even lease them to other people, OSHA's going to get involved with that and have to approve them first. So that's going to be limiting, right? Because they can build these things, but then it's like, if they can't sell them or lease them, that's a problem. So can Tesla absorb that many within its own company to proof of concept them? in the short term prior to, and maybe their suppliers and stuff, who knows, maybe they can sign these contracts that are like, yep, we waive all rights to whatever, and we're happy to experiment with. There would be companies that would do that, that would be happy to do that.
Yeah. All right. So my theory continues to be, and I'm just going to keep repeating it because I want to get credit. So 6 to 9 months of this in factory and possibly in supplier, taking these robots out, getting them socialized, getting them getting these tech guys used to the job of going out in the field and making sure that all these things work. So 6 to 9 months to get all that done. In the meantime, they're starting to build out whatever little motor lines they need and actuator lines that they need. So they're getting all that kind of stuff set up because they pretty well know what the robot's going to look like. And that is the big thing that even some of the competitors are saying that Tesla has this massive lead. The massive lead is their manufacturing capability and the fact that they're designing it to be manufactured. So that is the massive lead that they have. Some of the other guys might be leading in some of the hardware. They might be leading in some of the technical abilities of some of these robots, but not in designing it for manufacture and not in their manufacturing prowess.
Right.
So then
Scott, I'm curious, Scott, like how many, Fanuc or KUKA robots have been built in the entire history of, I mean, when will Optimus actually become the most manufactured robot in history? I'm curious because I don't think the number is that large, is it?
There's millions out there. I don't know.
Are there millions? Okay.
It was a slow ramp up.
Okay.
And they started to go, and then things got really crazy. And after 2008, they went like this. Yeah. And then in 2010, it started to go like this. Everyone's like, oh, is this a dead cat bounce? And then it's been going up.
Okay, so it's really taken off.
Then
okay,
the
cobots
have come in, the manufacturing costs have gone down. So it used to be you were looking at less than 100,000. And of course, the thing was like how you defined what a robot was. And that in Japan, they had a slightly different one that like any sort of automated mechanism that moved around, like almost was classified. Roombas are not in the classification, by the way. so if you're looking at the industrial robots, but it's for sure it's in the millions already. But once up there, it's going to be a lot. I saw the other day there was like another startup that I think OpenAI was investing in, 1X, with their Neo robot, and that prototype looks like it was really built with off-the-shelf robots. And John, I did a cost analysis on that. Remember, so it's got two arms. I mean, it has these grippers, these Robotique grippers, which are really nice grippers that go on a lot of cobots. They're like almost a standard out there, everything and having it, because they're very good at conforming on different shapes. Those are around $5,500 a pop. So right there, two hands, $11,000.
Whoa. Wow.
You've already got one or two Optimi right there. Then you have the arms, which it was kind of hard to find some numbers on them, depending on what you wanted, but it could be 35,000 for each arm. And then, you're quickly, and then it wasn't even talking about the head and some of the other things. So quickly that thing could have run up over $100,000. It's not scalable because I'll tell you, you go back to manufacturer and say, yeah, we'll buy 10,000 of them. And I go, what? We're not scaled for that. Because it's way more complex. They're very nice arms. They can do some really amazing things, but they have never had to scale quite to that level.
That was what I was getting at, was this idea of like, it's a whole different mindset. It's really different. Yeah.
Yes. It's very different. And they're like, one other point I want to leave you with, and that is, who invented the light bulb?
Well, everybody says Edison, but that's not.
Do you know, Randy?
I don't.
Okay. Humphrey Davy. Do you know what year?
Oh, it was a long time before, right? He just didn't have one that was very good. That was the problem, right?
1809. What Edison did was he invented the first practical
Yes.
Okay.
Yes.
And like in 1840, you had someone else who came up with one that was, a filament in a sealed vacuum tube that was just too expensive. And so the whole way technology works is that sometimes we associate a certain individual with the invention of that thing. And it wasn't necessarily an invention, it was an improvement. And Edison really had only one pure invention, and that was the phonograph.
Mm.
And that's why he loved it the most, because everything else was taking another invention and then improving it and getting a patent for that. So the point I'm trying to make is that, you know, it's a good chance everyone's going to say Elon invented the humanoid robot. No, he didn't. There have been attempts in walking robots that are going way, 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 way back. And it wasn't until 1880 that Edison finally said, I'm going to crack this problem.
Right.
And it wasn't that he had some insight. What he had was he rolled up his shirt sleeves.
Right.
He had what was described by one reporter as like over 1,000, you know, failures, because they kept on testing materials that didn't work. And Edison was like, those were not failures. Those were data points. And not only that, those things, they found out properties of those materials that they were then used in later inventions.
Right.
And this is the difference, is what's happening right now is rather than a couple of people tinkering in a lab, you know, working at that and say, well, isn't this rather interesting? It's a nice little curiosity, but, you know, it'll never be practical. We're going to stick with candles and everything else. Edison finally said, I think we can do this.
Yeah.
Elon's seeing the same thing. You know,
Yeah,
Steve Jobs saw the same thing. Convergence of technologies, everything is there. We can go ahead and do it. The history books could decide who gets the credit for everything else. You know what? I don't think Elon cares
No.
whether he gets the credit or not. He's just like,
I mean, hell's bells. Let's look at electric cars. They were invented in the 1800s. Electric cars were better and for a period of time more popular than gas-powered cars.
Yes.
It's just where the focus ended up going.
Yeah. It just shifted. So
What
it really comes down to is someone realizing how to take some old tech or some old ideas and finally be able to make them practical.
Yeah.
And that's what I'm seeing right now is this is our 1880 moment.
Yeah.
With
that's a great
humanoid robot.
That's a great summary, and it really summarizes kind of what I've been seeing from day one when I first saw that robot, where again, maybe one of the things that I bring to the table in this community is the fact that I really was a manufacturer, and I really did go out on the floor every single day, and I did invent methods and procedures as well as products that could be made in my factory, and that caused me, I think, to have a different viewpoint when I saw that robot. It wasn't the same as somebody who has never been in that same situation. So. Yeah, Scott, that's a great summary of how I've seen it all along. Thank you guys again for coming on the show. This is commonly the most popular show I'm doing is when I have the two of you on. And so I'm always glad to have you back as often as you'll come. And so if you like this show, like it, subscribe, hit the, you want to get more of this, you have to hit that notification thing if you want to be notified. I notice my notifications are going up dramatically because I keep on telling you to notify. So hit the notify button, would you? So, and then get on John's channel. Scott, you've got a channel now too, right? You've got a.
Oh, not really. I don't post weekly or anything like that. It's just if I've got something that's worth people viewing and bringing into their own YouTube videos, it's there.
Well, you should definitely subscribe and hit the notification bell for his channel, because when he does have something, it's usually very good.
Yes, it is. That's absolutely true. Yes. And John, of course, subscribe, and also to John and my Patreons. Okay, that should solve it for today. Thank you guys again. And for all of you out there, it's been great talking to you.
Click the link below to get your paperback, Kindle, or audiobook now.